Hey guys, Mr. Wilhelm here. Today we're going to complete the Turgor Pressure Lab. This lab is in the plant unit, which is unit number 8. To begin with, you will need to read the introduction portion of your lab, which is right here. Once you have read the introduction portion of your lab, you will need to go on down to the back page and complete the pre-lab analysis questions. Questions 1 and 2, you can get the answers from the introduction section of the lab. 3 and 4 are more of a hypothesis type situation. You're going to hypothesize as to what you think is going to happen to the 2 potato slices. Also, go ahead and even though you're not physically completing the lab procedure, you need to go ahead and read through this lab procedure so you have a little bit more of an understanding as to what we are doing. So at this time, go ahead and pause the video. Go read the introduction section of the lab, answer the pre-lab analysis questions, and then when you're all done, come back and unpause the video and we'll continue on with the lab. Okay, we're back. Hopefully you read the introduction section and answered those questions. Let's go on and go through this lab. Now, in this lab, we're going to be measuring turgor pressure. Turgor pressure is a water pressure. It's a pressure that you find inside of a plant cell. Turgor pressure enables the plant cell and then the plant as a whole to stand upright. It gives it support. It gives it a rigid structure. Okay. Let's go ahead and take a quick look at a plant cell. Here is a plant cell. Let's look at some major parts of the plant cell. The cell wall, that outermost layer of the plant cell. The vacuole, that center semi-transparent organelle in the plant cell. And then the chloroplast. We've been talking about chloroplast lately with photosynthesis, and this is where photosynthesis occurs. Let's focus in on this semi-transparent structure, the vacuole. Now, in the vacuole, it's very similar to a balloon, a water balloon. Okay, it holds water for the plant. Also, when that vacuole is full of water, it provides stiffness and support for the plant cell. The water is pushing out against the plant cell walls. Okay, that pressure, that water pressure inside the vacuole is pushing out against the vacuole and then ultimately against the plant cell walls, giving the plant cell some support, some structure. If you can imagine a water balloon being full of water versus a balloon having no water at all. A water balloon is still flexible, okay? However, it has much more support than a flimsy, empty latex balloon. So this is where we find that water and turgor pressure. So now we're going to measure and see how turgor pressure affects the structure of the plant, the stiffness of the plant. So here I have 2 potato slices. This is what I'm going to use. This is what I'm going to use as my plant cell sample. Okay, you can see that the 2 potato slices are roughly the same thickness and the same size. So to begin with, I'm going to find the mass of these 2 potato slices. One is going to be A, and the other one is going to be B. So I would take these over to the triple beam balance or an electronic balance and find the mass of these 2 potato slices. Let's go back and look at your lab sheet. When we find the mass of the 2 potato slices, we're going to record that mass where it says mass of potato before soaking for A, which is salt water, and B, which is distilled water. So let's assume that for each potato slice, we have a mass of 10 grams. And we're going to assume that I just did such a good job of cutting these that each one is exactly the same. So mass of each one of these samples before soaking is 10 grams. Okay. So now we're going to go and we are going to fill our two weigh boats with our two liquids. Okay, weigh boat. They call this guy right here a weigh boat, usually used with a balance to help find the mass of liquids or powders. In weigh boat A, we're going to put a salt water solution. In weigh boat B, we're going to we're going to put distilled water. Okay, we're going to take our two potato slices that were 10 grams a piece in mass. We're going to put one in A and then the other one in B. And then we're going to allow those two potato slices to soak for roughly a 20-minute time period. Okay, so let's fast forward here and let's go 20 minutes later. So here we have A, and then here we have B. Okay, so let's go back and look at our lab sheet. Right, here we are. So to begin, we had 10 grams. Each potato slice was 10 grams before soaking, and each potato slice was 10 grams in mass after soaking. Or excuse me, before, but they're both 10 grams, I'm sorry, excuse me, before soaking. So 10 grams. You need to go ahead and write this data, this sample data set in, as I'm doing right now. And we take our two potato slices after they've been soaking for about 20 minutes, and we would find the mass of each one of them. Now we're going to find that the one that was soaking in salt water is now 8 grams. And the one that has been soaking in distilled water is now 12 grams. If we look at this section over here, we can find the difference before and after and use an A, or excuse me, a plus sign if there's a positive change in mass and a minus or negative sign if there is a negative change in mass. So salt water, it was actually lost a mass of 2 grams, whereas the distilled water, it gained mass of 2 grams. So go ahead and write this data set down, this sample data set down in the data and observations data table. Okay, let's go back and look at our potato slices or samples here. So, things that you can observe. First off, if I hopefully can show that this particular potato slice is very flimsy, very flexible, okay? It almost droops, okay? That was the potato slice that was soaking in letter A. That's the one that lost mass. Then I have the sample that has been in B over here. And this particular sample is very stiff, okay? Very stiff as opposed to the other. Okay. Now, so we obviously have a change in mass and we have a change in the stiffness of each one of those potato slices. Let's go back and look at our lab sheet. So, how would I describe the stiffness of the sample that was in saltwater A, I would describe this as either being not stiff, or you could even say flimsy. Okay, and then B being obviously the opposite. Okay, so you can see that in the salt water, we lost mass and it became flimsy or not stiff. And distilled in the B sample, distilled water, we gained mass and the sample became very stiff. Why do you think that is? Okay, you can go online and look at this YouTube video, and simply by clicking on the link or typing in that address, and then answer some more questions with regards to the celery and the turgor pressure that occurs with this celery in that video. And then once you've done that, go ahead and go on to the post-lab analysis questions. Obviously, if you have any questions, please make sure that you let me know, and we'll discuss this lab in further detail.